This video is going to be going over the graph transformations of the sine and cosine functions. So far, we have probably talked about the unit circle, and so you would know in the first 0 to pi radians that these would be the outputs of sine. Now, if instead I make a graph that is y equals sine of x, that I could then plot this table in the xy coordinate plane, and notice that it makes this curve, or what we call a sinusoidal function. You can see the mappings here from the unit circle straight over to those outputs of sine, and notice that your sine function increases from 0 to 1, and then decreases from 1 to 0. Remember in our unit circle for xy that I'm looking at my y's for sine. So my y's go up, my y's go down, then my y's go to -1, and then back to 0. And you can see that here on my sine graph. We can look at a similar type of scenario for cosine as well. The difference is cosine starts at 0, 1. So again, if you are in that like xy on your unit circle, I'm now looking at my x's. So I'm starting at 1 and then heading in towards 0. Then I go out to -1. And then I go back in towards 0 and then back out towards 1 as I go around my circle here. And again, here's a table of values if you want to make that connection. So the domain of sine and cosine is going to be all real numbers. And then notice that the range must be between -1 and 1. Since both of these graphs repeat every 2 pi, we call these periodic functions. What that means is f of x plus the period, or f of x plus 2 pi, will get you directly back to the original f of x value. 0 and then 2 pi, but if I go out here to another pi over 2 past 2 pi, then that's the exact same output as f of pi over 2. Same thing for cosine. We can do transformations on these graphs in the exact same way that we did function transformations all the way back to lines and quadratic functions. The big thing is figuring out what that period of the sinusoidal function is going to be. You can do that by taking the b value, the number inside, with your x, and then taking 2 pi and dividing it by that b value. If b is greater than 1, then the period would be less than 2 pi, and we're going to shrink the function horizontally. You can look at some graphs down here. So my orange graph is my original sine graph. Here, b is 2, that's bigger than 1. And notice that means I need to essentially have 2 cycles within a normal cycle of sine. That's what that 2 means. I need to double my x's in one normal period of sine. I would need to have 2 of them in sine of 2x. The opposite then is true if you have a b value less than 1. So in this case, b is equal to 1/2. Notice that I only have half of a cycle in a normal cycle of my sine function. So if I want to use the formula, I know that my period is equal to 2 pi over b. When I divide by a fraction, that's the same thing as multiplying by a reciprocal. And so you can see that the period of that function would be twice as big as normal. Let's look at this example right here. In this case, I have that b is equal to pi over 6, and so my period is 2 pi over 6. I'm then going to multiply by the reciprocal and see that my period is 12 normal units of x's. So from here back to here would be 12. I know that then halfway would have to be 6. And then I can also look at the maximum and the minimum and know that those must be halfway as well. Another key piece of our graph is our amplitude. Amplitude meaning how big your wave curve is going to be. We look at the absolute value of amplitude because if A is negative, then we're actually going to flip the graph. We'll do that in our example here. So if you notice, I gave the graph of f of x equals 4 sine here, but I want to know what happens when I have f of x equals negative 4 sine. Well, that negative in the front says to flip your y values. So instead of going up and back down, I would go down. I would start still at 0, 0. I would go down and then back up and then hit here. I have nothing inside, so this is going to have a period of 2 pi, pi in the middle. But instead of going up first, I'm just going to reflect those y values over the x-axis. And so this is a stretch vertically. All right, let's go ahead and put this all together in our big forms. So notice when I have this form here, that really in order to graph and get the correct vertical shift, I need to factor out the b in both of those pieces. Okay, so in order to get the correct vertical shift, I have to factor out the b in both of those pieces. If I just had sine of x minus pi, well, b is 1, so I have a normal period of 2 pi. And then the minus pi tells us that I need to go to the right pi units. Now, the nice thing about pi is moving left and right here by pi, it doesn't really make as big of a difference, but there's one normal period of the sine graph. And then notice here, my sine minus pi, that it's moved to the right one. If I was looking at sine of x minus pi over 4, again, my period is 2 pi. I didn't have any multiplier inside to change the period of that function. And now I need to move everything to the right by pi over 4. So notice it starts here and then makes its revolution there. The other shift we can do is we can move up or down. So that's going to be with any number on the outside here, and then that's going to create your midline. It's going to basically move what would be your x-axis up or down to that d value. All right, here is an example. We're going to go ahead and do all of these shifts right here. So I have an a value of negative 2. I have a b value of 2. I have a c value of pi, and I have a d of 3. Now remember, to actually get that shift on the inside, I'm going to need to factor out a 2. And when I do that, I need to divide c by b. Divide c by b. To get my shift. All right, so my normal cosine function would start at 0, 1. It would have a 0 at pi over 2, negative 1 at pi, 3 pi over 2, 0, and 2 pi 1. Let's go with the shift first and then apply the period. So I need to move all of those points to the left by pi over 2. So I'm just going to move my first one here. I need to move it to the left, pi over 2. And then I need my period to be just pi. So I need to get back to this top part, pi units from here. So by this point here. Therefore, I know that all of this, normally I would have like pi over 2 in between, like pi over 2 and my x's here between each one. But I need this to go twice as fast so that my period is pi. So pi over 4 now kind of becomes my marker for that. Okay, and so that's the like inside x shifts. Let me change my color here. I'm then going to apply the -2. So that's going to stretch this by 2, 0, dun, 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 dun. But then it's also going to reflect. All right, one last piece. I'm going to change my color one more time. I'm now going to move each and every one of those pieces up 3. So 1, 2, 3, 1, 2, 3, 1, 2. I'm here, sorry, 5. And then make that nice and symmetric here. And so this is going to end up being my one period of my graph. And notice that my midline got moved up here. All right, let's try to go the other way. So if I give this function right here, can I try to find the formula for sine? Well, the first thing that I notice is I have been shifted up. So it looks like y equals 2 is my midline. The next thing that I notice is I have one cycle. It looks like every 2 pi. So my period is normal. My period is 2 pi. And then it looks like my amplitude is 1. And it doesn't look like I have any shifts at all. So I would have 1 sine of, since my period is 2 pi, 1x, I don't have any shifts. And then I'm just going to add 2 like so.